In the construction industry, every day brings the possibility of a new set of circumstances and a different set of potential hazards. Among the most serious of these are fall hazards. Everyone knows the dangers of falling. But as you work in a construction environment, your surroundings become more familiar and the work can become routine. You may begin to let your guard down, and that's when most accidents occur. You might be thinking to yourself that falls on a job site are rare. But statistics indicate that falls are a leading cause of death and injury in the construction workplace. Falls from almost any height can lead to disability or even death. In fact, half of all falls that end in death occur from heights of less than 20 feet, which is shorter than the height of most extension ladders. In a fall, it takes the average person at least 1/2 a second just to realize that they are falling. In that same time period, they have already traveled over 4 vertical feet. By the time they begin to realize that they are falling, they have fallen over 7 feet, too far in most cases for the individual to save him or herself. Only 1 second after the fall began, the unprotected individual will have dropped at least 16 feet. Fortunately, proper planning, including proper training and the correct use of fall protection equipment, can help prevent accidents from becoming fatalities. In this program, we will discuss when fall protection is required, the different types of fall protection systems, when each might be used, as well as additional considerations for a fall protection program. By learning and following these safety procedures discussed in this program, you can help make your workplace a safer environment. Not just for yourself, but for everyone. You probably already know that OSHA requires fall protection for most situations where there is a chance of a worker falling 6 feet or more. Many employers and project sites now require 100% fall protection anytime a worker has the chance of falling more than 6 feet or more, and you yourself may choose to use fall protection even where it's not required to help protect yourself, your coworkers, and your loved ones. No matter what your role is on a project site, to stay safe, it's critical that you understand when fall protection is needed and how to use it correctly. Whenever possible, the best fall protection strategy is to eliminate fall hazards altogether. This can sometimes be accomplished by keeping workers at the ground level. For example, using a tool extension to reach an off-the-ground task. If elimination of fall hazards is not an option, another approach is to use fall protection systems that prevent a fall from occurring or equipment that minimizes potential injury to the worker by arresting a fall. It should be obvious that arresting a fall after it has happened is the least protective and least desirable method of fall protection, as injuries can still occur. Different work environments call for different kinds of fall protection. Protection may include guardrails, covers, safety nets, fall restraints, and personal fall arrest systems. Whatever system your employer is using, remember, you have a responsibility to know and follow procedures for safe use. Now let's take a closer look at each of these methods of fall protection. Guardrails are probably the most common fall protection system found on construction sites. A guardrail is made up of a top rail, a mid-rail, a toe board, and posts. When constructing the top rail, OSHA requires that it be between 39 and 45 inches above the walking or working level, unless specific conditions warrant otherwise. The mid-rail is then located halfway between the top edge of the rail and the walking or working surface. Different materials may be used to construct a guardrail. Wood, metal pipe, structural steel, and cables are all good choices. Make sure to always use material with a smooth finish that won't snag clothing. cause lacerations, or create a trip hazard, as these are all situations that may cause a worker to fall. The top rail must always be able to withstand a force of 200 pounds when in any outward or downward direction, without deflecting more than 3 inches, or dropping below 39 inches. The mid-rail in a guardrail must be able to withstand a force of at least 150 pounds applied in any direction along the surface. And finally, with all types of guardrail construction, make sure there is no overhang of the top rails or mid-rails on the end joints that could cause a fall by catching clothing or creating a trip hazard. If constructing a wood guardrail, use stress-grade construction lumber for all pieces. The post and top rail must be made from 2x4s, and the mid-rails must be made from at least 1x6 lumber. When constructing the rail, post must be spaced no more than 8 feet on center. If using metal pipe, the post, top rails, and mid-rails should be at least 1.5-inch diameter Schedule 40 pipe. And again, the post must be spaced no more than 8 feet on center. If you are constructing a guardrail using structural steel, make sure to use at least 2x2 by 3/8-inch angles for the post, top rails, and mid-rails. And as with wood and pipe, all the posts must be spaced no more than 8 feet on center. If using cable, the top rail should be at least 1/4-inch nominal diameter thickness and must be marked at 6-foot intervals with a highly visible material so that it can be clearly seen. Never use steel or plastic banding for the top or mid-rails. While OSHA has no spacing requirement for the post and cable guardrail systems, because steel cable is heavy, additional post will likely be required to prevent the top rail from sagging more than 3 inches or below 39 inches above the walking or working surface. Corner posts will likely also require gussets to withstand the bending forces imposed by tightening these cables to meet the height requirements. It is important to note that in addition to the OSHA requirements, many contractors now require an additional guardrail at least 60 inches high near window openings and other penetrations. Work on ladders, stilts, or scaffolds adjacent open-sided floors may require that the guardrails be raised as well, or that employees tie off within a defined distance of the edge. For all types of guardrail systems, toe boards are the final bottom pieces. They are attached at the walking level and help to prevent tools and objects from slipping over the edge and falling onto someone below. Toe boards must be made of wood or other solid material. They must be at least 3.5 inches high with openings no more than 1 inch at its greatest dimension and no more than 1/4 inch below. They must be able to withstand 50 pounds of force in any downward or outward direction as well. Remember, toe boards can't prevent tools or materials that are piled higher than 3.5 inches from falling over the side, so be prepared to add mesh or netting as needed to the top rail height to prevent loose objects from falling, possibly injuring people below. It is also important that, as with all types of fall protection, you continue to regularly check guardrails for wear or damage and replace or repair as necessary. The next type of fall protection equipment is a cover. Covers are protective structures placed over holes and openings to prevent falls. Covers can provide effective protection, but like all fall protective systems, they must be installed and used correctly. OSHA requires employers to keep covered any gap or void 2 inches or more in dimension on a floor, roof, or other walking or working surfaces. Many skylights may also need to be covered or otherwise protected as well. Covers should be made of a strong material that will support twice the combined weight of the worker, equipment, and materials, and twice the maximum weight of the axle load of any vehicle expected to cross. When using covers for fall protection, make sure you write the word hole or cover in large, easy-to-see letters so that the covering is clearly visible. It's a good idea to write this in all of the languages spoken on the project site, so it is made very clear to every worker. Safety nets are another type of fall protection equipment. Safety nets may be used where guardrails or other types of fall protection systems are not practical. Safety nets don't prevent falls, they arrest them. In other words, safety nets lessen exposure if a fall does occur. To help ensure protection, safety nets must be of the approved type and used in accordance with the manufacturer's recommendations.
Safety nets are made of strong synthetic material, with open spaces in the net never wider than 6 inches. Safety nets are installed as close as possible to areas where people and objects might fall, and never more than 30 feet below the area that they are protecting. Net extensions, or how far the net reaches out, can vary from location to location. As a general rule, the longer the possible fall, the bigger the net. For example, if a net is 5 to 10 feet below a walking working level, then the net would need to extend out at least 10 feet. But if the net is 10 or more feet below the working or walking surface, then it needs to extend out at least 13 feet. Depending on your needs, it may be necessary to use more than one net to achieve the correct extension. If this is the case, make sure that any connections are no more than 6 inches apart and that the connections are just as strong as the nets themselves. It should be noted that many jurisdictions require persons who install or maintain nets to be licensed. Be sure to check your local requirements if using a net on your project site. Regularly test a net in accordance with OSHA and manufacturer requirements to ensure that it will work in an emergency situation. And remove fallen tools and materials that have collected in the net immediately. You wouldn't want someone to experience a fall and be injured by landing on tools or scrap material collected in the net. Also, on a weekly basis, check the net for mildew and signs of stress or other wear. If you suspect a problem, remove, repair, or replace the net immediately.
Yet another type of fall protection device is a fall restraint system. Fall restraint systems may be used in areas such as
loading bays, some roofing applications, decking, precast installation, or masonry or carpentry work in an area where guardrails must be removed to complete the work.
The requirements for fall restraint systems are very similar to the requirements for personal fall arrest equipment.
But the key here is to restrain workers from a fall. This means understanding the geometry of the area and the limitations of the equipment, and arranging it all so that a worker is physically prevented from falling over the edge or into the opening. Proper planning and choosing the appropriate equipment are critical when using fall restraint systems.
Now let's discuss personal fall arrest systems. This equipment is designed to protect the worker in the case of a free fall. Safe use is critical when using a personal fall arrest system and could make the difference between life and death for a worker who is in a free fall.
During free fall, body weight combines with speed and distance to propel a worker towards the ground or other surface with tremendous momentum. When the worker is stopped by hitting the ground or an object below, the sudden impact causes injury or death. A personal fall arrest system is designed to protect the worker from being injured by arresting or stopping a fall. The personal fall arrest system is made up of 4 components: the full body harness, connecting devices, a lanyard, and an anchorage point. You must understand each of the parts and how they work together to ensure that you are using your personal fall arrest system for maximum safety. Before working at height using PFAS, you should ask yourself, could I fall? What could I hit if I did fall? And how will I be rescued and how soon? As with all safety equipment, always inspect your personal fall arrest system before use. Check the harness, snap hooks, lanyard, and anchorage point for evidence of damage. Look for tears, cuts, breaks, frayed areas, pulled stitches, burns, and chemical corrosion on any object. Do not attach any foreign objects, such as tape or wire, to any component. Be sure that the inspection tag is legible and that a competent person has indicated his or her inspection within 6 months of your usage date. A full body harness is the only equipment that is acceptable for fall arrest. A harness works because it distributes the force of the impact of a fall evenly across the thighs, shoulders, and pelvis, helping to reduce the risk of injury. But remember that hanging in a harness for an extended period of time after a fall can cause injury too. So proper inspection, maintenance, and wearing of the harness are critical to its success and to your health and safety. When putting on a harness, begin by lifting it by the back D-ring and shake the harness so the straps fall into place. Check that all the buckles are unbuckled and make sure to straighten twisted straps. Slip one arm, then the other through the shoulder straps, making sure the D-ring is between the shoulder blades. Pull the back half of each leg strap forward and connect it to its front half. Next, connect the chest strap and position it at mid-chest. Tighten this strap to keep the shoulder straps in place. After all straps are buckled, tighten each buckle so the harness is snug without inhibiting movement. It should be noted that most harnesses aren't designed for more than a 310-pound combined worker and tool weight, and that manufacturers have designed harnesses built especially for women or for climbing or for rescue.